Start looking at section 3 of chapter 5, evaluating trig functions. And first we're going to look at the right triangle and trig functions from there. So if we look at this right triangle on a xy axis, the base here would be our x, right? And the height of this right triangle would be our y. And the distance to 0 would be our r. And if you can remember, this is the same thing really as absolute value of a complex number, so it might be a long time for you to remember that. But this point right here, say at the end, would be x comma y, right? So our height would be y, x would be our distance from along the x-axis, and then r would be our distance from 0. And so if we look at this right triangle, and we're looking at, say, this angle from here to here, so this is the angle that would represent this right triangle. Well, our sine of this angle is y over r. Well, that's the same as the opposite side of this angle, right? The opposite side over r, which is r is the opposite of the right angle, so that would be the hypotenuse. We can do that same with the other three functions, cosine and tangent. So we get sine is y over r, but it's also opposite over hypotenuse if we're looking at a right triangle. Same as adjacent over hypotenuse for cosine, and tangent would be opposite of adjacent. And then their reciprocals, of course, would be flipping those fractions. Right? Cosecant of the angle would be flipping the hypotenuse over the opposite side. So this is looking at a right triangle, and we can remember this by SOHCAHTOA. SOHCAHTOA. S stands for sine, O for opposite, H for hypotenuse, C for cosine, A for adjacent, H for hypotenuse, and T for tangent, O for opposite, and A for adjacent. And you always, when you do the right triangle, you always want to identify what is that hypotenuse, what is your R first, and it's always across from the 90-degree angle. Once you have that, then you can reference any angle. So I could reference, say, that if this is angle alpha, I could reference this angle, right? So the sine of this angle would be opposite, which is x over y, okay? Or opposite, sorry, sine would be opposite over hypotenuse, so x over r for this angle, right? But this one, all these right here, all these 6 go off of this angle theta. Now let's do some examples. Okay, so we want to find the trig functions. That means all 6 of them. Okay, so we're finding the trig functions of the acute angle, right? So we're actually going to do both of these. So we can do angle A first. So what is sine of angle A? Sine is opposite over hypotenuse. Right, so what's the opposite side of A? Is 7, and the hypotenuse is 25. It goes cosine of A, adjacent, which is next to or connected to A. That's not 25 because always identify that hypotenuse first, right? So the adjacent is 24 and the hypotenuse is 25. And then tangent is opposite over adjacent. Okay, now we can do their reciprocals. Cosecant would be 25 over 7. Secant of A, right? I always put my angle in there. It's not just secant equals, equals 25 over 24. It's secant of angle A, right? You have to identify which angle you're talking about. And tangent of A, because as we'll see next, or sorry, not tangent, we already did tangent, cotangent. Because as we can see, after I do this one, after I do cotangent here of angle A, which is 25 over 24, we can see, based on the angle, my answer will be different, right? So now let's look at angle B. What is sine of angle B? Sine is opposite is 24 over hypotenuse, 25. Cosine of B is adjacent, 7 over 25. And tangent, I'll let you fill in the rest here, the reciprocals. Tangent of angle B is opposite over adjacent, right? So as you can see, my answers are different, right? Based on what angle I'm looking at. So that's why you always have to have your angle here. Now, what do you notice though? Notice that sine of A is the same thing, same answer as cosine of B. And cosine of A is the same answer as sine of B. Well, how can that be? Well, notice that we have a right angle here. So that means these two together, this one, angle B and angle A, have to add up. They are complementary, right? Measure of angle A plus measure of angle B equals 90, right? If I add them together, they will equal 90. So if I have one, if this is 35, you can tell me what this one is, right? It'll be 45. Or actually, 55, sorry. Would be 55, right? So here we can see that sine, we'll say, even though that's not true, sine of 35 equals 24 over 25. That's not true, but I'm just going to put it in there. But cosine of 55, isn't that the same as 24 over 25? And I can rewrite this as cosine of 90 minus 35, right? Because 90 minus 35 is 55. I can rewrite 55 as 90 minus 35. And that's what you'll see later on as we talk about cofunctions, and that's kind of going to be in the next video. Okay, so let's go ahead and do the homework problems. So page 508, just number 1. So practice that, finding the trig functions of a right triangle using SOHCAHTOA. So we're going to look at this right triangle. We're just going to find sine of A, cosine of A, and tan of A. That's all they ask us to find. So we don't have to do all 6. Okay, so I'm looking at this angle. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tan is opposite over adjacent. Right? So I always identify that hypotenuse first, okay? Especially because when you do cosine, you might think 29 is adjacent, but it's not, right? It's the hypotenuse because it's across from the 90. So sine of A is equal to opposite over hypotenuse. And usually just leave these as fractions. If they don't simplify to an integer, leave them as fractions. Okay, just simplified fractions. Okay, cosine would be adjacent, so that's not 29, it would be 20 over the hypotenuse, 29. And tangent would be opposite, which is 21 over 20. So go ahead and leave those as those type of fractions. You can reduce them, but these ones you can't. Okay, so that's it for this video.